All right, well, 9F through I, same thing. We want to find the vertex, but it's not in vertex form this time. So one thing you could do would be to use the formula x equals negative b over 2a. Negative b over 2a will tell you the x value of your vertex. So if I want to use that for this function, then I know my vertex is going to be at negative b would be negative 8 over 2 times a is 1. So negative 8 divided by 2 is negative 4. So I know negative 4 is the x value of my vertex, and then I could just plug negative 4 back into my function to find the y value. So I could say negative 4 squared plus 8 times negative 4 plus 7. So negative 4 squared is 16 minus 32. 8 times 4 is 32 plus 7. Negative 32 and a positive 16 gives you a negative 16. So this becomes negative 16 plus 7. Negative 16 plus 7 is negative 9. So my vertex has to be at negative 4, negative 9. But let's look at another one right here. Again, G, I'm going to use that x equals negative b over 2a. You could also complete the square to find the vertex. So let's plug in negative b. Well, b is negative 50, so negative b is positive 50 divided by 2 times a is negative 5. So I have negative 50 over 10, which means I have negative 5 as the vertex, or rather as the x value of my vertex. And if I want the y value of my vertex, I plug it back in. But here's the thing, I don't really want to do all that multiplication. So what I'm going to do is I'm going to use an idea from our Unit 4 on polynomials. I'm going to take this quadratic, negative 5x squared minus 50x minus 135, and I am going to divide it synthetically by the x value, negative 5. Because when I do that, it will tell me the value of my function at that x value, which is what I want. I want the y value. So drop down that negative 5. Negative 5 times negative 5 is positive 25. Negative 50 and a positive 25 gives you negative 25. And then negative 5 times 25 gives you a positive 125. If you have 5 quarters, how much money do you have? You have 125 cents. So negative 135 and a positive 125 means those numbers are 10 apart. 135 and 125 are 10 apart, so we get a negative 10 there is my answer, which means the y value of my vertex is negative 10. So negative 5, negative 10. Remember, that is called the remainder theorem. It says when you divide a polynomial synthetically by a number, the remainder represents the value, the y value of the function at the x value that you divided by. It will allow you to do something like that more easily without a calculator. Let's go ahead and do the same thing with h. I'll use x equals negative b, so that will give me a positive 40 divided by 2a, so 2 times 8 right there. And let's go ahead and figure out what this number is. Well, 40 divided by 2 is 20, so I'm left with 20 over 8. Both of these numbers are divisible by 4. 20 divided by 4 is 5. 8 divided by 4 is 2, so I get 5 halves. Except I messed that up. I said 2 times 8, but really should have been 2 times 4, because my leading coefficient is 4. So that would get me 20 over 4 here, which means that I don't get 5 halves, I just get 5. 20 divided by 4 is 5. So 5 is the x value. What's the corresponding y value? Again, you could just plug it in, but the remainder theorem will allow you to find that value in an easier manner. I think it's easier to do some simple multiplication and addition than it is to do like big multiplication thingies. So bring your 4 down. 4 times 5 is 20. Negative 40, positive 20 gives you a negative 20. 20 times 5 is 100, so that gives us a negative 100 right there. So my remainder is a positive 6. And so I know that my vertex is at 5, 6. Let's do this one last one. Then we'll move on to the next type of problem here. Y equals x squared minus 2x minus 5. Now, if I'm being real with you, if I wanted to complete this, if I wanted to find the vertex of this and I was doing this problem, I wouldn't use negative b over 2a. You absolutely could, but I would just complete the square, because completing the square on this one is straightforward. X minus 1 squared minus 5 minus 1. I'm subtracting 1 from the 1 squared inside, so I get x minus 1 squared minus 6, which tells me my vertex is at 1 comma negative 6. So you can always use negative b over 2a to find the x value of the vertex. Then you can plug it back into the function to find the y value. If you're feeling fancy, you could use synthetic division and the remainder theorem to find the y value. But you can always complete the square as well. You can also find the vertex by using the quadratic formula if you were crafty. So there are different ways to go about it. You need to go about it in the easiest way.